This is the ultimate retro console that lets you enjoy Game Boy, NES, Sega and many more right from your couch. In this video I will show you how I made it along with its custom PCBs, cooling system, wireless controller and many more. You will get to see months of design and prototyping, and trust me, not everything went as expected. So sit back, relax and enjoy the journey. The console I have shown you previously on my channel was great. Handheld, light, basically perfect for travel. But there was one big issue with it. Whenever I got home and wanted to play something retro, pulling it out in front of two big displays just felt wrong. But still, playing 20-year-old games on a modern gaming PC with an Xbox controller was never going to be a vibe either. I think you get the idea here. I needed something that I could plug into any display, maybe with HDMI for convenience, but still something compact so that I can bring it over to my friend's house if I ever wanted to. And then it revealed itself to me. The Raspberry Pi Zero 2W. It's cheap, has good connectivity and it offers better performance. All of that coupled with the fact that there is officially supported software dedicated to retro emulation basically made it a perfect fit for the project. Let's now act as if there is no RAM shortage and I didn't overpay twice for a $15 computer, and just carry on. As this project was basically meant to be my prime potato couch setup, I needed some sort of wireless input. To fit all of the retro machines that we were going to emulate, I went with a basic D-pad-centric design, but since I was in charge of it, I decided to have my own spin on it. And so I kind of just put a screen in the middle. Just before you say it's a gimmick, hear me out. Battery percentage on the screen, charging indicator on the screen. And there's more. Due to my sincere hatred of setting screens, I decided to make it so that with a single click you could swap the entire button layout to one that lets you control settings. For example, volume with up and down, or basically shutting down the console with a single click. And those settings were basically going to be displayed on the screen for better user experience. Okay, so we've got some buttons, a screen, and I still needed a way to wirelessly connect to the console. I am personally not a big fan of pairing controllers or needing drivers, so seamlessness was my #1 priority. It turns out that our old friend ESP32 has a dedicated low latency data transfer protocol, ESP Now. Basically, we take two ESPs and tell each other what is their friend's MAC address, which is basically kind of like an internet name tag that every device has. Kind of like an IP address, but permanent. Then we tell one ESP to listen to his friend and tell the friend to, well, speak to the first one. And this way we have effectively created a transmitter-receiver relationship between the two. In our case, the transmitter was going to be the controller, shouting out which buttons are being pressed. The receiver was going to be the console itself, basically passing signals to the Pi via GPIO pins. Then a piece of software called GPIO Next on the Raspberry Pi was going to emulate those GPIO signals as button presses within the games. Pretty complicated, I know, so let's stop this nerd talk and let's actually build something. Alright guys, so welcome to our workshop setup. Here I have the prototype, basically got a ESP32S3 in the middle. Also we have a battery popped right in. So the rest of the stuff that I gotta do is plug in the screen that I've talked about. And yeah, basically this whole prototype will be ready to go. The prototype was indeed ready, but you know me, and jumper cables were never something we were going to settle for. So I opened my favorite design software and got to work. The controller board was basically a matter of a correct button layout. I opted for a JST connector for the battery this time and a circuit that detects charging and basically switches the ESP power supply from the battery to the USB, so you can still display a nice charging animation on the screen, for example. The console PCB had to be compact because I wanted it to function as a hat for the Raspberry Pi. I fitted all of the components tightly together and even fit a speaker inside for some retro soundtracks. And when both boards were done, I was ready to send them over to this video sponsor, PCBWay. PCBWay were kind enough to send me both boards along with the stencils for this project, and I couldn't be happy with the results. Not only did the boards arrive in just 2 days, the quality was amazing. One thing I was particularly happy about were the stencils. Not only were they just perfect in thickness, however they also cut them to size. I believe this side speaks for itself, so anytime you need any boards, stencils, assembly or even machining, check out PCBWay through my affiliate link in the description down below. It is also a nice gesture to support the channel. Huge thanks again to PCBWay for sponsoring this video, and let's get back to our project. With the boards finally in hand, there came the cruel process of manual SMD assembly. The compact form factor of those tiny components comes at a cost of time if you're willing to do it all by hand. The workflow was basically applying solder paste, component selection, and then 2 hours of assembly.
Yeah, so it's basically like 2 hours of this and you're done. If one thing was fun about this process, however, it was the reflow. Check it out. This comparison is truly the reason I make custom PCBs for my projects, but at this point we still had some soldering to do. Now all we need to do is basically solder in all the through-hole components and we'll be good to go. Alright guys, so welcome back to the microscope view, I guess. Well, I had to do, a checkup on the board if everything went alright. I have a problem with this port due to, as you can see, 3 bridges between those two, as well as those two, you cannot see the color red. Those lanes in the middle are especially important because they are data lines, so not to get too technical, but we're pretty much cooked and I have to make this stuff over by hand. So yeah, let's get to work. Alright, so the way we're gonna do this is basically... Alright, so welcome to day 2 of assembly. Basically, this is our board, and yesterday I kind of missed my sleep schedule a little bit. As you may remember, the pins were bridged and now they aren't, so I guess it's nice. But the next step is kind of scary because we actually have to plug it in and see if it works. Alright, so first rail should be 5 volts. We go here and here. And that's nothing. Wow. Maybe I've plugged it in the wrong way or something. I don't know. Modeling the console case was basically compromising between 3 components: the Pi with its I/O ports, the PCB with its own caveats, and the fan, which turned out to be a little bit taller than the stack-up itself. This made me develop this ledge-like design, but I think it turned out quite nicely. When modeling the controller, since the console was meant to be called the Nexus, I incorporated this X shape into the controller's design. I think it complements this screen-centric layout here, along with creating this inset for this accent piece with my logo on it, which we could also print in an accent color later on. Speaking of printing, I also got this new gray filament that I believe will create a nice retro vibe. The console unit, however, will just live next to my display, so I'll stick with a clean white color for this part. The controller consists of 4 parts that basically nicely slot into each other and hold quite tightly. The grips add a little bit of thickness and comfort. This small box creates the space for the battery, then the top half closes everything up, and the accent piece is a cherry on top. Then, with some editing magic, we have the buttons in place as well. Now comes the part I was not so sure about. So this is the ready bottom half of the case. I believe the print turned out really well. This part was basically printed on supports, but the text is still visible, so I guess that's fine. We have to do a test fit to actually see if it works. So yeah, the Raspberry Pi does have some sticking out I/O ports, so I don't know if this is gonna fit, so let's just drop it in and check. So here we go, I guess. And okay, yeah, it actually fitted pretty well. Now I guess all we have to do is print out the top half and check whether if our PCB is gonna fit. So my original idea was to basically put it all together right now, but there's actually one more thing that we can do to improve the Raspberry Pi's performance. The console is finally ready, and I cannot possibly tell you how happy I am to have gone through this process. As you have seen, the console works great. It's seamless, works great on large displays, and remember all of those cooling elements we have added? Well, the Pi doesn't get even remotely warm, even when streaming onto a large 4K display. I still have some things to update, such as the UI on the controller screen and some software-related things. However, literally in the middle of filming this video, I had my final exams, which basically delayed this video for over a month, so I'm not gonna bore that with you guys, and this has been enough of a wait. I have a lot of new content planned for this summer, so if you've enjoyed this video, consider subscribing, because even bigger projects are coming. Thank you so much for making it to the end of this video, and I will see you next time.